Hey guys, and welcome back to Study Journey. I'm back with another problem of the week, AMC 10B problem, and this is on palindromes and probability. So combining these two together to find the probability of a number that is a palindrome in a range of numbers. If you don't know what AMC is, make sure to check out my video linked down below, and without further ado, let's get on with the video. This is AMC 10B problem 21 of the year 2010. A palindrome between 1,000 and 10,000 is chosen at random. What is the probability that it is divisible by 7? So the keywords here are palindrome, 1,000 and 10,000, random, and the probability that it is divisible by 7. And here are your answer choices. A palindrome in math would be like a number that is read the same forwards and backwards, like 1, 2, 3, 2, 1. It would be the same forwards and backwards. A number between 1,000 and 10,000 would have 4 digits. 1, 2, 3, and 4. And then how can we represent this in a form that is a palindrome? Well, let's let the number on the ones place be A0, and then the one on the tens place will be A1 times 10, and then this would be A2 times 100, and this would be A3 times 1,000. And for this to be a palindrome, A3 has to equal A0, and then A2 has to equal A1, because remember, it has to be the same forwards and backwards. So if this was 1, 2, 2, 1, that would be a palindrome. Since we know this has to be true, then we can simplify this equation. So that the number would be A3 times 1,000 plus A2 times 100 plus A2 times 10, and then plus A3. And then if we simplify that, we get 1001 A3 plus 110 A2. And it is asking what is the probability that this number would be divisible by 7. Well, let's see if any of these coefficients are divisible by 7. Well, 1001 divided by 7 is equal to 143 with a remainder of 0, so it is divisible by 7. And then 110 divided by 7 is not divisible by 7. So since we know that 1001 is divisible by 7, then 1001 times A3 is divisible by 7. So when A2 is equal to 0, the number would just be 1001 times A3, which is divisible by 7. Well, how many palindromes would be possible? Remember, it is 4 digits, and the first and last is always A3. And since A2 is equal to 0, the second two numbers are 0. So how many possible numbers can A3 be? Well, it can be 1 through 9, but it can't be 0, because if it was 0, then this would just be 0, and it is not a number between 1,000 and 10,000. So there are 9 possible palindromes. Okay, so what about when A2 is not equal to 0? One number can A2 be so that 110 times A2 is divisible by 7. Well, A2 can only be 7, because since 110 is not divisible by 7, for this number to be divisible by 7, then it has to be 7. So if A2 is equal to 7, then the number would be, the two 7s are in the middle, and these would be A3. Again, A3 cannot equal 0, or else the first number would be 0, and this would be a 3-digit number. So again, there are 9 possible palindromes. Now we just have to find the total number of palindromes between 1,000 and 10,000, meaning if it was a 4-digit number, because it is a 4-digit number, how many possible palindromes are here? A3 can be a number 1 through 9, and then A2 can be a number 0 through 9. Remember that A3 can't be 0 because it is the first number of the 4-digit number. So this will be 9 possible numbers, and this will be 10 possible numbers. So the number of palindromes here would be 9 times 10, which equals 90. 90 different types of palindromes. The probability that the palindrome between 1,000 and 10,000 is divisible by 7 would be these two, 18 over 90. And then if we simplify that, we get 1/5. And then looking at the answers, we can tell that the answer will be E, 1/5.